This week in lab, you're going to be doing what's known as the Wittig reaction. And this reaction is used to convert aldehydes and ketones into alkenes. So one of your starting materials is always going to be an aldehyde or a ketone. So let's just say this ketone. Your other reagent is a special Wittig reagent. And the Wittig reagent is a phosphorus ylide. And the way that is generally drawn is we have triphenylphosphine, and the phosphorus is double bonded to a carbon, which can have one or two R groups on it. So what happens in just this generic Wittig reaction, and the way I like to think about it is the triphenylphosphine and oxygen, those pair up to give you your byproduct, which is triphenylphosphine oxide. But then the carbon of your aldehyde or ketone, along with the carbon of your ylide, those pair up to form the new carbon-carbon double bond. So it looks something like this. Let's first take a look at how you prepare the ylide that you're using in lab. In this case, you're using this alpha bromo ester, and the first thing you need to do is incorporate the triphenylphosphine. So you start with this organobromide and add triphenylphosphine to that. This phosphorus has a lone pair, and it will add to this carbon. The Br will be displaced in what is essentially an SN2 reaction. So what we now have is a bond to the phosphorus. It still has the three phenyl groups. Because we added that new bond, it's positively charged. And then we also have the bromide ion. So this is considered your triphenylphosphine salt. We still don't have the ylide yet. To get to the ylide, you have to add a base. There's various bases that can be used here. A common base is butyl lithium, or it could just be some alkoxide base. What that does is it deprotonates one of the alpha protons in this molecule. So let me just draw one in. This proton, even without the ester, is especially acidic because the neighboring atom has a positive charge. So the base will come and take this proton, and that will push these electrons onto the carbon as a lone pair. So here's what we get. So you can certainly draw your ylide like this, but it doesn't quite look like the ylide I have up here. And that's because there is a second resonance structure you can draw. So what we can do is take the electrons on the lone pair and just move those here to make a pi bond between the carbon and the phosphorus. And the phosphorus can have more than an octet of electrons, so this is okay. So these are the two resonance structures of the ylide. Now what we do is we take this ylide and react it with benzaldehyde, And just like we saw in the introduction, the triphenylphosphine and the oxygen, that will go away as your byproduct, which is a white solid triphenylphosphine oxide. And your carbon of the aldehyde will now be doubly bonded to the carbon of the ylide. And in this reaction, with this particular ylide, the E alkene is preferred.